How do you fix JavaScript memory leaks from detached DOM nodes? Imagine your web page is a busy city, and every DOM node is a building. Sometimes, buildings are torn down, but the city still keeps holding onto old blueprints. That's what happens with detached DOM nodes in JavaScript. They are elements removed from the page but still referenced somewhere in your code. This can cause your app to slow down or use more memory than it should. So, how do you clean up these leftover buildings? Let's walk through it step by step. First, it's important to understand what a detached DOM node is. When you remove an element from the document object model, or DOM, it's no longer visible on the page. But if your JavaScript code still has a reference to that element, the browser's garbage collector can't free up that memory. This is like leaving old blueprints in your storage room even after tearing down the building. To fix this, you need to make sure all references to these nodes are cleared. Start by removing the nodes properly from the DOM. Use methods like removeChild or the remove function on the element itself. For example, if you have a parent element and a child element, call parent, remove child. This tells the browser that the node is gone from the document. But don't stop there. You also need to clear any JavaScript variables that point to that node. Set those variables to null after removing the node. For example, child element is equal to null. This breaks the reference chain and allows the garbage collector to do its job. Event listeners are another common cause of memory leaks. If you attach an event listener to a DOM node and then remove that node without removing the listener, the reference to the node stays alive. Always remove event listeners with remove event listener before or after removing the node. For example, element, remove event listener, click, handler function. This ensures no lingering references keep the node in memory. Timers and intervals can also hold onto DOM nodes. If you set a timer with set timeout or set interval that references a DOM element, clear it with clear timeout or clear interval when you no longer need it. This step is crucial in long-running applications or single-page apps where components are mounted and unmounted frequently. Using browser developer tools can help you spot detached DOM nodes. Tools like Chrome DevTools have a memory tab that shows retained nodes. You can take heap snapshots and see which nodes are still in memory even after you think you've removed them. This helps you identify leaks and fix them. In some cases, especially with dynamic textures or canvases, you might need to remove the element from the DOM and explicitly nullify its reference in your code. For example, if you have a canvas used for drawing, remove it from the document and set the variable to null. This prevents leaks caused by lingering references. Finally, consider using structures like weakmap for caching DOM nodes. Weak maps allow the garbage collector to free the key value pairs if there are no other references to the key. This helps prevent leaks in complex applications. By following these steps, properly removing nodes, clearing references, removing event listeners, clearing timers, and using diagnostic tools, you can keep your web page memory clean. This approach ensures your app runs smoothly and efficiently, even after many interactions and updates.